All right, so we're going to do example 2 with slope fields. So here we have a separable differential equation, which means we can solve it, and we'll be asked in part B to do so. But part A is just a slope field. So we have dy dx equals x over y, and then we're given that f of x, y equals f of x, is a solution such that f of 1 equals -2. All right, so first we're asked to find a slope field at the 11 points indicated. So how much work you show on a slope field is a little bit up to you, right? But you just don't want to be wrong, right? So a couple things that I noticed. So since my slope is is x on top of y, anywhere that x is 0 but y is not, my slope should be 0, right? X on top of y. So so if I write my points, right, I have -1 comma -1, -1 comma 0, -1 comma 1, and -1 comma 2, right? And then if I do the same thing but with 0 comma -1. I don't have 0, 0 as a point. It's worth noting on the graph that 0, 0 is not a point, and we'll talk about why in a sec. 0, 1, and 0, 2, right? And then lastly, 1, -1, 1, 0, 1, 1, and 1, 2, right? So how much work you do on this is kind of up to you. You just need to make sure your slopes are right? So x on top of y would give me a slope of 1, right? X on top of y is going to give me a slope that's undefined, right? And I'm just going to write und after this, or undef, okay? -1 over 1 gives me a -1. -1 over 2 gives me a -1/2. 0 over all of these non-zero numbers will give me 0. 1 over -1 is a -1. 1 over 0 is undefined, which we'll deal with in a sec. 1 over 1 is a 1, and 1 over 2 is a 1/2, right? So now when I draw my slopes, just like we saw in the last example, these slopes of 0, right, they're going to matter. So anywhere that the x-coordinate is 0, which means the y-axis, these are level slopes. So my marker is not showing up as super red anymore because I wrote on top of it already, but we tried. And anywhere I have undefined slopes, oh, green's the one that doesn't work, my bad. Anywhere I have undefined slopes, those should be vertical lines. So there's a vertical line here, and there's a vertical line here. My other slopes are going to be rise over run. So this slope should be up 1, right 1, which will look like this. This slope should be down 1, left 1. So there's my slope of -1. Down 1, left 2 is going to be slightly flatter, but still negative, right? Down here I have a slope of -1, right, which is down 1, right 1, so it looks like that. Here I have a slope of +1, so up 1, right 1. And then +1/2 is up 1, right 2, so a little bit flatter, right? So I didn't do a great job there, but that's the gist. Right, so again, remember on an AP, you're probably getting 1 point for all the weird slopes, like the zeros and the undefines, and 1 point for all the other slopes together collectively. The reason I didn't list 0, 0 is because on this graph it's not there, and the reason it's not is because that is an indeterminate form. We've talked about that before, but 0 over 0 is not a number. It doesn't behave like a number. It behaves in a lot of different ways. So the AP is not going to ask you to do the point that's 0 over 0 in general because there's no good way to draw that. So the next thing I'm asked to do is to actually find f of x to solve. Now this is a separable differential equation, so I'm going to multiply the y over with the dy, and I'm going to multiply the dx over with the x. I'm then going to integrate on both sides and find the antiderivative. So I'm going to get y squared over 2 equals x squared over 2 plus some c. We put all of our c's on the x side because if you think about it this way, there was an arbitrary constant here. There's another arbitrary constant here. I move all of them to one side, and sure enough, I get this random plus c, like c sub 1 and c sub 2 were combined to give me some c. I'm going to go ahead and solve for y because it specifically says at the top y equals f of x. It's up to you now if you want to plug in what c is now or if you'd rather solve. Me personally, I usually solve first. So I'm going to times everybody by 2. And when I do that, I'm going to get a y squared equals an x squared plus, I'm going to just go ahead and call this c sub 1 because 2 times an arbitrary constant is just a different arbitrary constant. And then I'm going to square root. So I'm going to get that y is plus or minus the square root of x squared plus c sub 1. Now my final answer is not going to have a plus or minus. If we look back at my initial condition, which was right up here, right, my f of 1 is a -2, even roots, like a square root, have a positive output. So what that means is if the output I'm supposed to get is a -2, that in this problem I want the negative. So I'm going to kind of squeeze this over here because I'm a little bit low on space for my part A, right? So I have y equals the negative square root of x squared plus the thing I called c sub 1. I'm now going to plug in my f of 1 is a negative 2. So negative 2 equals negative square root of 1 squared, which is just a 1, plus my c sub 1. So I get negative 2 equals negative square root of 1 plus c sub 1. I don't know why I just recopied the same step, but I'm going to square everything. When I square both sides, I end up getting 4 equals a 1 plus my c sub 1. So 3 is my c sub 1. And that makes my final answer y, which is the same as f of x, equals the negative square root of x squared plus 3. And that's my final answer and the solution to my Diffie-Q. Again, the trick here is that a lot of people are going to miss the negative in the square root.